Okay, this is question 10 from the most challenging paper 2 questions for this upcoming assessment. So it involves a trig sub, like they're telling us right away that we need to take x squared and we're going to substitute 2 secant x into it. So to do this, one of the things that we need to start with is let's do our work with the sub that we're going to have to do, because we know we're going to have to do a couple of things with it. So if x squared is 2 secant, sorry, theta, then if I take the derivative of this, d theta of this whole thing, I would get 2x dx d thetas is the same as 2, well, the derivative of secant theta, if we don't know it, we can use our formula booklet, but it should be secant theta, oh my goodness, secant theta tangent theta, yeah. So that's going to be 2 secant theta tangent theta. Again, we're going to want to know what dx is. So dx is going to be 2 secant theta tangent theta. We're going to have d theta over here, and all of that divided by 2x. Well, we can get rid of the 2's, and that gives us a value of dx. So we've got dx, and dx is going to be secant theta tangent theta all over x and then d theta. Additionally, in every single one of these trig subs, at the end of it, we need to know what theta is in respect to x. So in order to do that, we just need to do a little bit more work with this in terms of solving for x. Actually, solving for theta is what we're going to be doing. So if I do that, I would end up with secant theta is x squared over 2. Okay, but we're told that we need to have this as arc cosine. Well, arc cosine, or cosine, is secant, or secant is cosine over 1. So I could rewrite this as cosine theta is just the inverse. If I just invert it, because again, the reason why that happens, x squared over 2 would be 1 over cosine theta. So I would multiply by cosine theta, I get cosine theta times x squared equals 2. So cosine theta is 2 over x squared. What this allows me to do is now to get an expression for what theta is, I would have that. Note, that is exactly what this bit is. So I'm feeling really, really, really good about where I've gotten to. So these are the 2 little bits of work that we have to do. Why are we zooming in? Those are the 2 little bits of work that we have to do to be able to make progress on this. All right, so now let's get to the integration. The integration, we are doing the integral of 1 over x square roots of x to the 4th minus 4 is what we're after. And at the end of the day, again, this is what it should look like if we've done everything right. So with that, let's go ahead and substitute what we have. So I've got the integral of 1 over x square roots of, I'm going to do this in my yellow, that is 2 secant theta squared, and then minus 4. And all of that is being multiplied by secant theta tangent theta all over x d theta. All right, so doing just a little bit of combination here. Let's get this all together. So this would give me the integral of 1 over x squared square roots of 4 secant squared theta minus 4, and then that's going to be times secant theta tangent theta d theta, right? I just brought this x into here. Now, occasionally this is going to happen to us, but now I'm back to x squared, and we've already defined x squared as 2 secant theta. So I'm going to do some more substitutions here, and I'll be left with 1 over 2 secant theta times the square root, and I'm going to go ahead and factor out that 4. Secant squared theta minus 1, and that's times secant theta tangent theta d theta. All right, so bye-bye. Here, because I was able to factor out that 4, I can bring that 4 out as well. So that would give me 1 over 2 times 2 square roots of secant squared minus 1. And times tan theta d theta. All right, now we got to recognize what secant squared theta minus theta is. We kind of have a hint what it's going to be, but just so we can make sure we got this, if we go to our formula booklet, and again, whenever we see a trig sub, I recommend almost immediately you open your formula booklet to this page, because this gives us our identities. And right here, we can see the identity that we're after. So secant squared theta minus 1 would be tangent squared theta. So, working more with this substitution, I would have 1 over, and I'm going to pull, because there's 1/4 here, I'm going to pull that out just so I don't have to deal with it anymore. And that's going to be the square root of tangent squared theta, making that substitution from my identities. Well, the square root of tangent squared theta is just tangent theta. So I end up with tan theta over tan theta d theta. So that's 1/4 1 d theta. Well, the integral of 1 with respect to theta would just be theta. Right, and now this is where our work from before pays off, because I have already determined that theta is that. So that's going to give me 1/4 the arc cosine of 2 over x squared plus c. And I think that was the solution required. Yep. So that's the process. Again, whenever you do these trig subs, we need to anticipate needing to know our trig identities, and to be able to use those identities to solve out. We're always looking for an identity that's going to cancel. All right, hope that's helpful.